Section 2.3, Application Problems. In a runoff election for student government president, the Northerner reported that one candidate received 50 more than twice the votes received by the other candidate. If the total number of votes cast was 4,730, how many votes did the winning candidate receive? So we have two candidates, and the total number of votes is 4,730. So, one candidate, we'll say, received V votes. The other candidate received 50 more than twice that V. So this is our equation. How do we solve it? Well, let's first simplify the left-hand side. We have 3V plus 50 equals 4,730. Let's subtract 50 from both sides, and we get 3V equals 4,680. So now, let's solve for V. Let's divide both sides by 3. And that will give us V equals 1,560. Did the person who received 1,560 votes, did that person win the election? I don't think so. I think the person who won the election, and that's what we want, the winning candidate. How many votes did the winning candidate receive? So I think the person who received 50 plus 2V, and V is 1,560. I think the person who won received that many votes. So we can take 50 plus 3,120. So that'll be 3,170 votes. Another way we could have gotten that answer is we know altogether there are 4,730 votes. And if we subtract from that 1,560, you'll also get 3,170. So let's make sure we put this in a complete sentence. The winner got 3,170 votes. And that's our solution. A stock clerk earns $12.50 an hour for the first 40 hours he works, and $18.75 for each hour over 40. How many hours did he work this week if he earns $612.50? So he has regular hours he gets paid for, and then he has overtime. So the regular hours and the overtime. And if you add those together, you're going to get his total pay of $612.50. So he earns $12.50 for the first 40 hours that he works. That's his regular pay. He gets $18.75 for overtime. How many hours overtime? You know what? I want to let X represent the total number of hours that he works, because that's what we're trying to solve for. How many hours did he work this week? Total number of hours. So if we want to know how much overtime he worked, we have to take X, the total number, and subtract 40. You don't have to work the problem this way, but I just wanted X to represent what it is we're actually trying to solve for. So that's why I did it that way. So we need the 1250 times 40. So he's going to get $500 for regular pay. Now we need to eliminate the parentheses. So we take our 1875 times x minus our 1875 times 40. So that's going to give us 7, oh wait a minute, we need an x in there. And then we'll have 750 equals 612.50. So combining our like terms on the left-hand side, we have minus 250 plus 1875x equals 612.50. Let's add 250 to both sides. That's going to give us our 1875x equals 862.50. We need to get rid of that 1875x. So let's divide both sides by 1875. And that will give us x equals 862.5 divided by 1875. That will give us 46 hours. Now that's our solution. And let's write it in the sentence. He worked 46 hours. Period. So 2 trains leave a depot at the same time, traveling in opposite directions on the tracks. One train travels 10 miles per hour faster than the other. After 4 hours, the trains were 440 miles apart. What was the speed of the slower train? I think pictures help in a situation like this. 2 trains leave the depot, traveling on parallel tracks in opposite directions. One train travels 10 miles per hour faster than the other. So if this is the rate, then this one is the rate plus 10. After 4 hours, so 4 hours later, these guys are a total of 440 miles apart. So they remember that distance is rate times time. And looking at this drawing, we know the rate of the slower train is r. If we want to know the distance that that train went, we need to multiply that times his time. We know his time is 4 hours. We know the faster train, the rate is r plus 10. If we want to know how far that train went, we need to multiply him by 4. His time is 4. So that gives us that the distance of the slower train plus the distance of the faster train gives us our total distance of 440 miles. We need to solve this equation. Let's eliminate the parentheses. Let's combine our like terms. What's next? What do you want to do? Let's subtract 40 from both sides. And that gives us 8r equals 400. Now what? Let's divide by 8, and we get r equals 50. Now, r equals 50, that's a rate, and we're talking about miles, and we're talking about hours. So our rate is in miles per hour. That is the speed of the slower train. It was going 450 miles per hour. Our complete sentences don't have to be fancy. We just need a complete sentence to answer the question. A plane flying between two cities at 400 miles per hour arrives a half an hour late. If the plane had flown at 450, it would have been on time. Find the distance between the two cities. So we're going from city A to city B, and the plane flying at 400 miles per hour arrives a half an hour late. If it had gone between the two cities at 450, it would have made it on time. We want to know, what's the distance between these two cities? There's different ways to do this. I sometimes like to do my distance, rate, and time problems in a table. So I have two planes. I have one going at a rate of 400 miles per hour. That's the real plane, and then I have kind of my imaginary plane. If he had gone at 450, he would have been on time. So, let's think about this time business. If he had gone at 450, he would have been on time. So let's just call that T. On time. That's how much time it would take him. But since he went at 400 miles per hour, he was a half an hour late. So he took more time. Let's say T plus 1/2. Now, what is distance? Distance is rate times time. So our distance is 400 times T plus 1/2. What about our second plane? Our distance is 450 times T. But we know that these two planes are both beginning at city A and ending at city B. They're going the same distance. So our equation is going to come from this first column in our table. Our 400 times T plus 1/2 equals 450 T. So 400T plus 200 equals 450T. Subtract 400 from both sides, and we get 400T from both sides, and we get 200 equals 50T. Divide both sides by 50, and you get T equals 4. Time is 4 hours. Is that what we're looking for, though? How much time the plane would have taken had it gone at 450 miles an hour? Now the question is, what is the distance? Find the distance. Let's make sure we answer the question. Time is 4 hours. So if we put 4 hours in our box here, we know that our distance is 450 times our time, which is 4. That's 1,800 miles. Make sure you always answer the question that is being asked. Find the distance between the two cities. It is 1,800 miles. That is our solution. For the first 2 hours of a trip, a driver averaged 55 miles per hour. For the remainder of the trip, he drove at an average of 60 miles per hour. If the entire trip covered 140 miles, how many hours did the trip last? So we have distance equals rate times time. So our trip has two parts. For the first 2 hours, that's time, of a trip, the driver averaged 55 miles per hour. For the remainder of the trip, he drove 60 miles per hour. The entire trip covered 140 miles. How many hours did the trip last? So let's let T be the last part of the trip. We don't know how much time he spent driving 60 miles per hour. So if we want to know distance, distance is rate times time. 55 times 2 is 110. 60t will be our distance that we cover at 60 miles an hour. Now, we know that the first leg of the trip plus the last leg of the trip will equal 140. The entire trip covered 140 miles. So our equation we get from our first column, 110 plus 60t equals 140. Subtract 110 from both sides. 60t equals 30. Divide both sides by 60. And you get t equals 1/2. 1/2 of an hour. What is our question we're supposed to answer? How many hours did the trip last? Well, we know that we have 2 hours for the first part of it, and if t is 1/2, then the total trip lasted 2 1/2 hours. So it lasted 2 1/2 hours. A mixture problem. This is a classic math problem. How much pure alcohol must be mixed with 6 liters of a 60% alcohol to make a 70% alcohol solution? So we're mixing pure alcohol. Let's say we'll let that be represented by X. We're mixing that with 6 liters of a 60% alcohol solution. There are 6 liters of this liquid, but it's 60% alcohol. We're going to be dealing with pure alcohol here. We have pure alcohol that we're mixing in, and we want to know how much pure alcohol is in a 6-liter solution that is 60% alcohol. You want to take 60% of that 6 liters, and that will give you 3.6 liters. That is pure alcohol. Let's think about that. It's 6 liters altogether, and 3.6 liters of that is pure alcohol. Yeah, that makes sense. And it's a 60% solution. So if we mix our pure alcohol with the pure alcohol from our 60% solution, we'll get a solution that is 70% alcohol. Let's figure out how much pure alcohol that is. 70% of how much liquid do we have now? Well, we mixed our pure alcohol plus the 6 liters, so that gives us X plus 6, which will give us 0.70X plus 4.2. This is our equation. We're going to solve for X. Let's subtract 3.6 from both sides. And while we're at it, why not go ahead and subtract 0.70x from both sides? That will give us 0.30x equals 0.6. Divide both sides by 0.3, and we get x equals 2. Our unit of measurement is liters, so 2 liters. So we're going to add 2 liters of pure alcohol. And that's our solution. So now we have another combination problem. How many pints of a 1% solution of disinfectant must be combined with 4 pints of a 10% solution to make a 5% solution? So we need to figure out how much pure disinfectant we're dealing with here. How many pints? That's what we're solving for. So we're going to call that, we'll call that X. So the original solution is 1% solution. So we need to know what is 1% of X pints. That will be pure disinfectant. How much pure disinfectant will we have with 4 pints of a 10% solution? We need to know what 10% of 4 pints is. Be careful, when you change 10% to a decimal, it's 0.10. 1% is 0.01. 10% is 0.10. 0.10 times 4 will give us the pure disinfectant in that solution. 0.10 times 4 is 0.4 pints. So we have 0.01x plus 0.4 pints. Now, we added the first solution with the second solution, and we calculated how much pure disinfectant there was in each part of the solution. So now our resulting solution will be 5%, 0.05. How much liquid will there be once we mix X pints with 4 pints of liquid? X plus 4. And 5% of that is pure disinfectant. So we have the pure disinfectant plus the pure disinfectant equals the pure disinfectant. And if we eliminate the parentheses here, we'll have 0.05x plus 0.2. Let's solve this equation. Let's subtract 0.01x from both sides. Let's subtract 0.2 from both sides. And we get 0.2 equals 0.04x. Let's divide both sides by 0.04. And we get 0.2 divided by 0.04. 5 equals x. X is the number of pints. So we will combine 5 pints of a 1% solution with 4 pints of a 10% solution, and that will give us 5 plus 4, 9 pints of a 5% solution. So we need to add 5 pints. That's all for section 2.3 applications.